Hello and welcome to Design Patterns here on Code Tech Tutorials. Today we're going to look at a new pattern called the Proxy. Now what the Proxy essentially does is it puts a class in front of your real process that adds on a little additional functionality. So we're going to set up a new code spot here in our repo, link down below, and we're going to get this ready. Okay, and now with all our CMake set up, we can go ahead and start showing an example. So I'm going to write all the example code here in this proxy folder. We need a subject to operate on. I'm going to use the idea of a store, maybe an online store, and how they might or could tie some of their services together. Let's say from the store you buy items that are for sale. So we're going to have a class called item request. This is going to be an interface class. Now what we want to do in this item request is essentially have a base request item. Let's make this all verbal. Now we got to think about what happens when we request an item and what we might be doing here. If we leave it pure virtual, that implementation is going to be left up to whoever implements this interface. But we could give it a root definition, a base definition, in case no one overrides it. Let's go off an item SKU. For simplicity's sake, I'm just going to use integers, and I'm going to use an integer called item SKU. So essentially this would match with the available items somewhere on a database. We're not going to build that database, but just to give you an idea of how it works. So you request an item, and it returns void. That doesn't really work. We need to return something. So what we could do is we could also have a payment system. So that way it charges the payment system. Of course, this would probably be a more complicated struct, but we're just going to leave it as ID for now. We could even do it as a string just for more details, but yeah, I think overall, if this were real, this would just be a struct that has some details. In fact, let's go ahead and build that. What would payment details have? We basically want to know whether it's like a bank or a card, credit card. Let's just go with it's got to be some kind of digital pass in. There's no physical here in the code world, so no cash. So the payment details would have to be some basic thing like that. So to avoid complications any further, let's do some payment types. And we're going to assume, well, we'll have credit card and we'll have bank. Or maybe we'll also have wire. Let's also put crypto in here. So let's say we accept those payment types. Sounds good. Payment details is going to need a type, and it's also going to need, I guess, something else. So we'd have to think about how we're putting this in here. I think we're going to return just an integer or like the amount charged. So we could just have an interface that's something like this. Returns amount charged, or 0 if item is not found, or payment would not be. Okay, well, I guess we could have different error codes. Amount charged turns 0 if item not found, turns 1 if payment error, well, not 1, but -1. And we could go on here. Returns -2. Well, that's all we need for now. Payment error or item not found. Sounds good. So we have this initial request item. Maybe we don't. Well, let's do this. If we pass this in by reference, we can edit their payment. So we don't necessarily want to do that. So I think we're going to make it const. And we're going to take it in as a copy because we don't want any risk of any of these payment details getting changed. You could pass it in as a const reference. And you think that might be fine because, well, it's const. And they have a reference to the real thing. But the problem here is, in C++, it's a dangerous language. You can do a const cast and get rid of const and change the payment anyway. So for safety reasons, we're just going to take in a copy so they can't change the real one coming in. And sure, we'll make it const too. Item SKU doesn't matter so much, but we'll make it const. It's a less security intensive asset. Maybe we only need pay type, but yeah, let's just go with pay type. We don't need these details after all. Payment types is good enough. And in this code, we're going to pseudocode up a few things, but pretend this is talking to some kind of database. So we go if, but before this, we might actually have to connect to something like a database, or maybe it would just be like that. Let's go with inventory. And for this inventory, let's type def inventory as a vector of ints. So now this is just a vector. Go ahead and include everything we need up here. Vector. So basically, this would be more like a database link, but let's keep it simple here. So we go something like if current story dot, what is the function? I forget. Let me go look. So we could use standard find here, starting with the beginning of the inventory to the end of the inventory, and then what we're looking for, which is the item SKU. So if this returns not the end, so it'd probably be better to do this on its own line at first. A moment when you're too zoomed in, just trying to make sure it's visible. All right. So if this is not the end iterator, then we found it. If found is not equal to current inventory dot end. Item is in stock, let's say. So items, it might be better to do items in a way where it's like the SKU, and we probably want a count of how many are in stock, something like that. But then we need to think about ways to clean it up, because when it's out of stock, do we remove it from the inventory, or do we leave it there with a 0? So maybe that's getting a little, in the thick of it, and you're going to mess up our example. But if it's in stock, we would check the payment. So we need something here that would talk to the end too. Let's just make a function to pseudo that up. So we would go void. Oh, I guess items need a price too, don't they? Okay, I'll get this sorted out. We'll make a proper. We're going to have to skip over a lot of details because, well, the reality of this example is it's got to be simplified some. It's going to get way too complicated if I add every possibility and check every angle, but it's just an example. Let's go charge. So maybe we have a function that's called charge. Takes the payment and an amount to charge. For now, we're just going to return true, which assumes we charge the amount from the proper account. Now, this payment type you're going to have to think of as being more info, like all the info to do the thing, so maybe it sends a request somewhere else. But for now, we're just going to assume that this succeeds no matter what and returns true on the charge. So we would just go, if item is in stock, try to charge the card, theoretically, pass in this payment and an amount to charge. Now we don't know how much it's going to be, but we would have to check based on this. So let's work this up after all. We'll just call it item for sale. And that's what this inventory is going to be, a bunch of items for sale. Well, let's have the SKU, let's have the cost, and let's also have the in stock. In stock. That should be good. Now this gets a little trickier because it's a current inventory, and we need, instead of just item SKU here, it's obviously not going to be able to find that. So we're going to have to put something else here. Now I believe what we can actually do here is put a lambda. And basically we just go through the inventory and check it. Does this allow that? Let me double check. Okay, if we want to do it this way, you have to do find if, and this would have to take in an item. Const item for sale, just the members of this vector, basically. By reference, we'll just call it I. And now in the body of this lambda, we're going to say if I dot SKU equals item SKU and I dot num stock is greater than 0. If that's the case, we return true. And that'll be all we need for the find if code. So it implies that it returns bool. We want to make sure it understands that. We could put that here, like so, which is part of the lambda optional syntax. Otherwise, we want to make sure we actually return false. That's the fall through case here. Okay, so that's the default REST quest item. And you can see that, well, found is going to be a little different with find if, because this returns all of them that match. Now we know it should just be one, but the thing is, this is going to be, let's see if it hovers over. No, it's going to be an iterator. So it's going to be a little bit different. Let's go ahead and just make sure this compiles. It's, okay, so if the item is found, we essentially want to return the amount charged. So that's all we would do. If found is greater than 0, it means we found an item in stock. Now, find if can make quite a large array or list or whatever you're working with, vector. But in our case, there should only ever be one match and one item in stock. We could make more sure of that with better management of how this works, but we're kind of overlooking that. Because, you know, technically we could make a bunch of items with the same SKU. This should be unique, so we probably have something to make sure that's unique. So just assume that, maybe we will even put that in here. Assume unique SKU can't be multiple. All right, well, that's just an assumption we'll make, even though it doesn't quite fit the data type correctly. But let's just continue. So found at size is greater than 0. We assume that the one in the front is the 1. So we'd return cost per. This only requests a single item. I guess you'd have to call it a bunch of times to keep getting the same thing. And once the amount is charged, we want to reduce the count of that. So actually we do found up front dot num in stock minus. So there we go. That would reduce the number in stock. However, it won't actually, because this is just a copy. It's not the real inventory. So that's not exactly going to work like we think it will. This return is fine. If we want to actually reduce the front, we might need to use other methods. For me personally, this whole find if kind of complicates the whole thing. So I'm going to just rewrite this in a better way that I like better. So essentially, we just want to go through the inventory. So let's just do that. So let's just make a auto reference to an item. Go through the inventory. And this is going to simplify it a lot because we can just do the direct check. Item.sku if it equals item SKU and item dot stock greater than 0. And we return the item cost per. And if it goes all the way through this loop without returning the cost per, well, let's make sure to reduce it. So this minus minus would work because it's a reference to this current inventory. So that will work properly. And then we'll return that and we're good to go. Next time you go to check, it's possible that the num in stock is no longer greater than 0 and it won't find it. So that's an interesting thing. So we can return 0 if item not found. That would be like right after this. We don't have the we need to charge, right? So we would do that before subtracting the item. So if we find the item, it's in stock, and we attempt to charge. So let's just go if charge. So we need the payment passed in and the amount to charge, which is going to be this item.cost per. So if this returns true, then we return all this stuff. We say charge went through, subtract the item, tell them how much we charged them. And if it doesn't go through, so if it finds the item and in stock, and this charge fails, we want to return -1. as a payment error. So there's our base request item. That should work pretty well. So this is an interface class, but it's not a pure virtual interface class since we've defined request item. You could do it in a pure virtual way if you want. I'll leave that to you if you want. A lot of examples out there often do it that way, but I don't find it to be necessary for this more simple example. All right. So we've essentially got a thing we can use in our main, and this is the real item. What we're going to do now is put a proxy in front of it. So let's just test out the real one first, just to make sure it actually works. So we need a payment type, or payment, or we'll just call this storefront. Payment storefront. All right, payment, and we need our payment to, well, I guess we could be whatever we want to be. Let's just do a credit card right now. So, and then we just go well, we need to populate the storefront. It doesn't have anything in it, as you can tell. We could have it, give it a base instantiation of some stuff. Right now, it's just going to be no items actually for sale. So maybe we want in here an add inventory type of thing as well. But we've been a bit naive and haven't added that. Let's just do it, I guess. Add inventory. And we just take in items for sale. And we could define this as just exactly what you would think. Current inventory.pushback. Item for sale. We could make this virtual in case they want to override it as well. If we're doing that, we probably want to make this protected rather than private. That way, if you're inheriting, you can still write functionality around current inventory. And there we go. So for now, we can just pass in a few items here, something like this. It was SKU, cost, and number in stock. SKU, cost, number in stock. Now, is it going to like that we have instantiated this inline? I don't know. It might confuse it a bit. Let's just put in a couple different things here. So it kind of makes sense that we let things stay in inventory with 0 in stock, because that would kind of give us a flag to replenish. If something runs out, we try to get more type of thing, but that's for a later setup. Let's see if this code actually works. We can actually push this back. So the thing to do currently would, if you try to add inventory, we got to think about this a little bit. If it already exists, so let's take this same code here, go through all the items, see if it matches this new item SKU. If it does, we would just add that to the inventory with a plus equals. So we could just do that. And of course, if this happens, we want to be sure to return, not push back the new one. So this would be not allow duplicate SKUs. Instead, add to num in stock. So there we go. So if it goes through all this and doesn't find a duplicate, then it just pushes back a new one. It's a pretty fine add inventory request there. So let's just go ahead and make sure this runs. I'm going to switch this to Proxy. Where's Proxy? I don't see it. Oh, we need to add it to one more CMake here. The level above it. Be sure to add Proxy here. Now it should show up as soon as this is done. There it is. Okay. And let's just hit play and make sure everything succeeds. We have an error. Okay, there's that. Can't have a return type on a destructor. Am I doing this type def wrong? I think I am. I think I have it reversed. I think it's like that. We say this item for sale is called inventory. Right, let's try that now. Okay, I think this is okay. What's it complaining about? So we got an if statement here, statement here. Oh, this item. We need num in stock here. Minus, minus. And we need another parentheses there. So this returns the charge. Right? Okay. Yeah, that was it. Because this returns a boolean. In our case, it's always true because, we haven't implemented a true payment system, so we're just assuming the payment works. But we do have a way, in case it fails, to return payment error. So that's something we could do later if we want. That's getting into the real world, so we're not going to go there. Okay, it all compiles and looks fine. So you can kind of use this. You can request items. So you got all this storefront. Now we're in client world, so you would want to just basically do stuff like our storefront dot request item, and we'll have a return code here. Just make it auto for now. And what item do we request? I don't know. We need a SKU, so we'll put in some random numbers, and then we want our payment to be passed in here as well. Details. If we're really going further with this, we could say shipping detail, all that stuff, but maybe that would be a great proxy, actually, to put the shipping on that, because that's essentially what you do with proxies, is you usually add some additional stuff to whatever it was before. Let's go ahead and display our output here, and we get code 0. What is code 0? Well, we can take a look at it and say item not found. Okay, interesting. Yep, that actually makes sense. There is no 234 in here, but if we look for 233 item, let's see what happens. Actually, let's just copy all this code down. And let's hit play again. It is, oh, we're saying return code twice. So let's go like that. Okay. So for the first one, we got a 0, or item not found. The second one, we got a 6, which is the cost. There's the cost. So that works perfectly. Okay. So if we take it a step further and make a proxy, we can do some special stuff. So while our current item request works fine, what we could do is we could say we'll put another front on it so that we can gather shipping before we request the item. So what we do is we just go class proxy for address, and we will take in, or we are going to include this item request here as part of this class. Now, if this were a pure virtual interface class, we would want to hold a pointer to it. Let's actually just real quick make that base interface. Let's just call it a request, all right? And in here, this is where we're going to have this virtual. All the same stuff here. This time it's going to be equal 0. So that way, I have to implement it in this item request. And we do need the constructor here too. There is a virtual add inventory as well. So we could put that in here and make that equal 0 too. So now we have an interface that can't be instantiated on its own. It has to be overridden, and all these virtuals declared with override. I don't think we need virtual over here on the left side, but I'm going to leave it to see if the compiler complains. Now this inventory could probably go up to here. Yeah, and that would be fine. So there we go. Now we've got an actual interface. So in this case, what we would do here is we call this one just is this interface here. Let's make a proxy. Let's make a proxy of the item request. So here's the proxy for address on request. I'm going to make this descriptive and long. Proxy for address before buy. Okay, super long class name, but just roll with it. It's fine. Just want to make it clear. So in this, we already got all this request stuff, but of course it needs overridden, or so you would think, but we can make a private member here that is called item request. Make it a pointer. right, and then publicly, we're going to have the constructor so that we can set this, and it would look something like this. Proxy. We have this whole name, constructor, and we want to put in this item, like so. We'll just call it item rec. Alright, and then we want to just instantiate this, like so. Just do new item request. Pass this pointer. We got to dereference it like that, and we got to put brackets over here for anything else. But that should be fine. All right, then we want, of course, a destructor publicly here that just deletes the item request. Destructs, and that should be mostly ready to go. So we can add in some more private stuff here that we want to do, because we already know that this item request is going to have this whole instantiation here. But now, since this proxy for address implements this request, we also have to implement these still, which is actually okay. But it also means that this can stand in this interface. So rather than the old item request, now we can put a proxy on top of it. So I'll go ahead and show that. So first of all, we need to implement a few more methods here, like basically all of these. Any of these overridden ones, we also need to override. But rather than call everything we've already called and rewrite this sort of thing, we just do it like this. Just push it to there. Does that make sense? Pass this along. And same thing here. But the whole point of the proxy is to do a little additional stuff. So that's probably what we want to do and have some private functions. Let's do a check payment here. Now, we said that this is for address. So, you know, we could add on an address and write a whole new function for all of these that does such a thing. But let's keep it a little simpler, okay? Let's just make this check a few things before doing the request. Check before item request. That's what we're going to call it. That's what this proxy is going to call it. So forget about the address. We're going to totally skip over the address factor overall. Of course, you'd want to work that into your real system, but let's keep the complications down. So what we want to do here, if we add inventory, for example, that can probably stay the same. We could add a check before and after if we want. Yeah, let's actually do it. Let's say maybe we want a little bit of a log. So let's go void log inventory add. And this will just take in the whatever details about it. So rather than be a function, obviously we could even just put this code right here because we're going to call this. And we're just going to say, we'll just do a cout. Attempted to add, you know, we can, we could put further checks in here to say like if it added and all that kind of stuff. We can do a whole bunch of additional queries up in here. I'm just going to keep it simple, but we might do it before and after, see if it actually got added, that sort of thing. But for sake of time, I'm going to kind of skip over that and just put this this quick attempted to add SKU. So that should give you an idea, because essentially the rest of the stuff would be the same. So now we still have an add inventory, but now it also logs. So that's one thing you can do. And we could do the same thing with this request item. For example, we could have a payment check or something. Turns a true or false, just takes in this payment. And we could do our own pre-check on the payment if we wanted before trying to actually charge. Pre-check payment for legality or something. You know, just some basic stuff. Make sure that the card isn't expired or something like that. Sure, account exists. slash card isn't expired, etc. We're going to assume pass for now. Sudo code. So we're just going to return true for now. But pretend this was the elaborate system that did some additional checks, right? So we could do that here. And the reason this would be good is we could not even, like, maybe we don't even want to send the request. Like, if we know that the payment is not good, let's not even go further. So we could go if not paid. So if this returns false, then we would return, I don't know, we could go ahead and stick with the original payment error. We'll return -1 a little sooner here. It's a little proxy check. And we could also, if we want, we could do a initial query on the item SKU maybe. I don't know, that's going to be kind of hard because the way we got it worked up. But that's the point of the proxy here, is to basically be able to add some functionality and pretend to be the interface that you want. So let's have a look back over here. So we have our storefront, it's got items. What if instead of item request, it was now a check before item request? Now you can see that it doesn't really like this, right? Okay, so let's put the old one back. Let's go, now let's make this proxy store. Now, of course, it wants the same one, so, or it needs something to instantiate. And it wants a pointer, so we're going to have to do a reference here. There, now we've got a proxy store. And we can still do the same thing on this proxy store instead of our storefront. And get some return codes and whatnot. So let's go ahead and have a check of that. We've also got new add inventory functions, so we could test one of those. Let's go ahead and just put one down here. And this one should log. Let's just add some different details. 9, let's say 2 in stock. So make sure that we're called proxy store here. Proxy it. Real store, proxy of it, and here's our client. Run through the proxy. Okay, so let's have a run of this code. We should definitely see the add inventory. These should work just fine. And well, we got an error. Okay, so we need to include IOStream in this header. I believe we have a C out somewhere. And I'll say play. And there we go. So we got an attempted to add SKU. So that worked okay. We got a couple return codes -1. Now, I didn't really expect this. I thought that one of the return codes would be successful. We're getting -1, whereas item is not found. So there's something happening there that's not working quite right, because this one should work okay. So we can put a breakpoint here, put this in debug, and see what's going on. Hit F11. And then hit F5 to go all the way down here, and then F11 go into this. And let's see what's happening here. It looks like our payment check might be backwards. It's returning true, which turns into a false. It skips over it, very good. Oh, we're not returning here, so we should be returning like that, because we want to return whatever this returns. So that's the entire problem with the code, I believe. It's a stop. Go back to release. And hit play. Now it looks better, more like what we expect. Return code 0 for the one that's not found, return code 6 for charge 6, and that's doing it through the proxy. So you can see how proxies could be interesting and also scary. For example, a hacker might put a proxy over something and just skim a little of the payment off the top or something like that. But, you know, that's the scary black hat of the whole operation. But generally, you're just adding some functionality. Hope you guys have enjoyed this episode and have a better understanding of what a proxy is and how to implement it in C++. This code will be up on GitHub. If you enjoyed the video or learned something, consider hitting the like button. And if you want to see more of these videos, consider supporting the channel. I do have a Patreon. It's up on the channel page. A link to it is. And we have a Discord if you want to talk about code and all kinds of cool stuff like that. So, yeah, have a peek around if you want. I'll see you later. Map Code Tech Tutorials over and out.